Hi, so this video is going to go over the battle between source set and media queries and which you should use and why. So I've done some research, I've made some demos, and I've written a very in-depth article about this, but this is a video version of that same article. So let's get started. The issue is that nowadays all website pages that we make are responsive. That is to say that the mobile version, the image is on top and the text is under it, and the desktop, both of them take up half the screen, right? So all layouts are now responsive. They are just based on the dimensions of the device on which they are viewed. So this brings up a question: what should the pixel size of the image be? Now, you could run into a few problems. You could make the image a little bit too small, and if you do that, then it'll look blurry on some devices. Or you could make the image too large and just be safe uh, and solve the blurry problem, but then you would be sending out these massive images on devices that really don't need them and sending all this extra data to the user, making your page slow. The problem gets much more complicated because there are so many different screen sizes that people use nowadays across their devices, whether it's mobile phones and tablets and so on and so forth. And worst of all, Google is not particularly happy about this bad experience that you provide to your user if you don't size images properly. So if you run it a badly sized images on a page through the Google Page Speed Insights tool, you'll get a properly sized images error. And also the Core Web Vitals release that Google is doing right now sort of looks at the user experience that the user is having as they reach your website and says, hey, that's kind of a bad experience. They don't need such large images. And they will penalize you for that. So if nothing else, you need to take this entire subject quite seriously just to appease Google. So let's try to attempt to solve the problem with media queries. And this is not the right tool for the job, so that's why, spoiler alert, it's not really going to work. But let's go ahead with it anyways so that we understand what the problems are. So this is a screenshot from the Bootstrap 5 media queries. We're going to use that to try and take some inspiration and figure out what sizes of the image should we produce. And I'm going to use this placeholder.jp service to quickly generate these placeholder images. So that will keep things simple. So I'm just going to generate all of these images and add some bootstrappy type of class, and then I'm going to add all these media queries, and you can go into all of them in detail, but as of now that's not particularly important. What you need to see is that this is a demo that I'm running over here, which is using those media queries. And as you can see, I'm on a mobile device, and this image 576 by 576 is chosen. And I'm on a desktop device, this 700 pixel image is chosen, and so on and so forth. So it looks like the correct image is being chosen based on the device, and that's good. But there are two problems with this approach. Failure one is that even though only one image is display blocked, so what we have done is basically we have all of those images one under the other, and only one is display block at the time, and the rest of them are display none. And even though one only image is display block, if you ask the browser to load the page and you open up the network tab, what you will see is that all the images are loaded. So we were trying to reduce the amount of data sent to the user, but now we have 5x the amount of data that is being sent to the user, and that's bad. So that's the first failure. Now the second failure is a little bit more complicated to understand, but before that, let's quickly look at what solution can we do for the first failure. So there is a new attribute called loading equal to lazy. It doesn't have a lot of support, and that's one of the problems with that approach. But you could, in theory, add the loading equal to lazy attribute to your page. And let me just quickly show you the view page source. And here you'll see loading equal to lazy over here, right, for all these images. The benefit of that is that the browser doesn't preemptively load the images. It sort of figures out, oh, I guess there's only one image of 576 pixel going to be used, so I'm just going to load that one. And that's awesome. That solves that problem. So now we are not doing 5x the amount of images. But as I said earlier, the problem is that the support is 73%. Support will always keep improving, and you should probably use loading equal to lazy for all of your images. But as of now, this doesn't really solve our problem well. The second problem, which is the more elaborate problem to solve, is that let's try to simulate that particular solution on an iPhone 12. And Chrome seems to think that the iPhone 12's resolution is 390 pixels by 844 pixels. But that doesn't seem right, does it? Because it's an iPhone 12 and it has a very high resolution. This is what the Apple site says. It's 1170 pixels width and 2532 pixels height. So why does Chrome and the Apple site have different numbers? So all of this comes down to this problem called, which you might have heard of for sure, called that iPhone devices have a Retina display. What is a Retina display? I've linked to a video of Steve Jobs explaining what a Retina display is, and I really don't want to make my attempt at explaining it. I rather that you check out this video because he does a great job of explaining it. But the point basically is that a Retina display, they pack more pixels than there seem to be to give you a much sharper image. So over here, this is a non-retina blurry image, and on the right-hand side, there's a beautifully sharp image, and that's what a retina display is. The problem with that, of course, is that our media queries seem to think that the width of this screen is 390 pixels. So based on that, they chose this 576 pixel image, which is going to look extremely blurry on an iPhone 12, whose actual width is 1170 pixels. Here's some JS you can use to quickly check all this. So there is a piece of JS called window.device pixel ratio that says, okay, how many pixels are there for one virtual pixel? So the answer to that is 3. I can multiply that by 390, which is what Chrome is saying over here, and that's how I get the actual width of this particular image, right? So our media queries don't account for all that, and that's why we get this tiny image on the iPhone. Now you can solve that problem too with some more media queries. There are two problems with that. Firstly, those media queries are not well supported. Here's a can I use screenshot. Okay, a lot of support, 97%, 79%. Then they're there, but not quite there, unprefixed, as in, without the WebKit prefix. Having said that, the bigger problem is that your code is going to get even more complex, and we already wrote a lot of media queries. The source set solution to the problem is so simple that you rather use that. But you got to learn a little bit of something new. So let's try to do that. So next we're going to try to solve this problem with source set, and this is basically the syntax that is needed. As you can see, it's basically a normal img src tag, which you know from the very first day that you started learning HTML. There's a new attribute called source set, which is basically a set of sources. And what we have done here is we have given a lot of different images, and next to each image, we are giving the browser some indication about what is the width of this image in pixels. Okay, so that's why there's a new strange unit called W, and it's not exactly px because we are not accounting for the height. So they created a new unit called W, and what we do is that we put the URL of the image and we say it's 768 by 768. So the width is 768, and we say 768 W. Okay. That's all we need to do with the sources. Put an image, space, the width of the image in pixels, and W after that. Lastly, we need to add another attribute called sizes. Now, what the sizes attribute does is it's a media query-ish attribute where we say min width 992. So it's saying, okay, anything where the width is minimum of 992, so it's like a desktop-y device, it's going to be half and half, right? So this image is going to take up 50% of the viewport width, VW, right? And if that does not match, then just the image is taking up 100% of the viewport width. So it's a very media query-ish way to try to communicate to the browser that how much of the width is going to be taken up by the image. So that's pretty much it for source set. And what we can do now is that we can come over here and look at the demo of the same thing using source set. Now again, I'm on an iPhone Pro, and on this iPhone Pro, again, the width seems to be 390. But look at the image that the browser picked up. The browser seems to have picked up the 1200 pixel image, which is perfect because the width of the iPhone is 1170, so it's slightly larger than the image needed. And we gave it all of these different options, right? We went all the way till 1500, 1700, 1920, and it picked the perfect 1200 one. So the point is that once you set up things with source set, the browser does all the heavy lifting, figures out the device pixel ratio, solves basically all of your problems. So that is why this is this approach you should use. And obviously, if I come to the network tab, and I refresh this page, you will see that only the 1200 pixel by 1200 pixel image was the only one that was loaded. So you're loading only the image needed. Also, the support for source set is obviously much higher, which is 94%. So I would say, hands down, source set is the dominant solution for responsive images, and you shouldn't consider using media queries. Now, what sizes should you make these images? Because now you're on board, you're saying that, okay, I'm going to use source set, but what should the sizes of the images be? So what we're going to do is we're going to take inspiration from the Next.js framework, which has source-set built in into it. Next.js is a React JavaScript framework for generating websites, and we're going to use that as a reference. And because we are assuming that they are doing some research and coming up with these numbers, and they basically generate all of these different image sizes. Now it may seem like, oh my god, this is a pain. Now I have to generate an image in all these different sizes, and that's a little bit irritating. You're right, it is irritating, but do not even think of doing it manually. What I would suggest you do is you check out my recommendation at the bottom of this article. It talks about using an image CDN. An image CDN allows you to take your image, change the URL parameters slightly, and generate a new image on the fly. And then it's the benefit is that it's a CDN, so it's the same image is cached all over the world and is served from the closest server to the user. So use image CDNs, generate your images on the fly, and solve the problem for good. So check out the article for all the details of this. I hope that everything that I've put into this article has helped you conclusively answer the question of media queries versus